positive. These are give a reason for your answer.
All right, so let's go to our card. So if we're looking at velocity, so here's our velocity. Let's write v. And here's our time. And I want to know, when is the acceleration of the car positive? So what time is the acceleration of the car positive? So if I know if the acceleration has to be positive, let's do a recap of the PVA card. The derivative of the particle is a velocity. The derivative of the velocity is the acceleration. So we know acceleration is the first prime of the velocity. So if I know the acceleration has to be positive, what direction is the velocity going? Has to go up. So let's put velocity must go up. So we're looking at the parts or the intervals where it's going to be increasing. So it is increasing at 0 for sure. And it continues to increase until we get to what number of the t-value? 35. Is that the only spot it's increasing? Nope. Where else does it pick back up? At 45 to 50. Very well. 45 to 50. And that is because the velocity is doing what? It is increasing. So that information is not new from last semester. Same with B and C. So on B, Jameson, let's read.
Find the average acceleration of the car in feet per second squared over the interval 0 is less than or equal to t less than or equal to 50.
So let's see if y'all recall of the average acceleration. Is that A-rock or I-rock? A-rock, average rate of change. And in this case, they gave us the interval already, so we don't have to start guessing. So we know it's a slope formula. It is a velocity, or v of 50 minus v of 0. It's basically y2 minus y1 over x2 minus x1. Then we have 50 minus 0. And looking at the table, you can look at the graph if you want. The table seems easier for the values. What is the value of v of 50? 72. What about v of 0? Also 0. And then the bottom is just 50. Let's type that in. 72 divided by 50. And the norm is 3 decimal places unless it terminates before that. 1.44. 0.44. And the units for this one has to be what? Feet per second squared. And I'm going to explain feet per second squared, even though it's already on here. I want to show you where that came about. So write this off to the side. To find the average acceleration, we did velocity over time. Is that true? Mm-hmm. So velocity, if you notice our units, it is feet per second. So let's write feet per second. Oh. And then our time is just in seconds. Do we see that the seconds on the top is on the denominator and the bottom's already on the denominator of the whole fraction? That's why it's second squared. If you want to write this over 1 and multiply by the reciprocal, it'll still give you second squared over on the denominator. All right? I know it was already on there, but it's good to kind of talk about. All right, part C, Alan, let's read.
Approximation for the acceleration of the car in feet per second squared at t equals 40. Show the computations that you used to arrive at your answer.
So if we are looking at the approximation, we have to use the numbers that are nearby. So let's go to 40. Here is 40. Is our slope at that point increasing or decreasing? Decreasing. It is decreasing. So can I use my two neighbors to see the approximated value, not the exact? You can. So in this case, shown acceleration. Let's write, and I'm going to write A-rock on this one again as a reminder. The two numbers side by side here is 45, so v of 45 minus v of 35 over 45 minus 35. And when I plug it in from the table given, it is 60 minus how many? 81 over, is that 10 on the bottom? All right, let's type that in. And as long as we know we have a decreasing function, it's still an approximation. It's not exact. Negative 2 point how many? 1. And again, this one is feet per second squared because it's the acceleration. And we talked about the units as to why that is. All right. Part D is review from the last time. that I saw you guys. I think it was like a Monday or Tuesday. Tuesday? No, Wednesday. All right. So further review portion. Ali, go ahead and read.
Approximate the interval from 0 to 50 DFT with the Riemann sum using midpoints of 5 subintervals of equal length using correct units. Explain the meaning of this.
All right. 5 sub-interval of equal length. And then we'll do the explaining part after the answer. But let's go to our table. If I want 5 sub-intervals that are equal length, it looks like I have to go from 0 to 10. Because if you notice, if the last number is 50, we know each one has to contain 10 units, correct? So I have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Any questions there? So if you want to do the same thing, go ahead. Right here. Because I kind of get a little dizzy when I have to look to the right side of with the line right here. Okay? And which Riemann sum are we asking for? Midpoint. And that midpoint is the middle number. So let's circle the middle number on each subinterval. And you should end up circling 5 numbers. So let's write the following. The first one that we have for the midpoint is 12. What are we going to multiply that 12 by?
5.
Ooh, is it 5 or 10? From 10, 0 to 10, 10 to 20, 20 to 30, they're equidistant by how many? 10. It is jumping by 5 on the table though, okay? Then we have plus 30 times, does that 10 change? Still the same, because it is equal subinterval. 70 times 10, plus 81 times 10, plus 60 times 10. Let's see what we get. Should be something in the 2000s. I guess if you're not using a calculator, I'm going to yank it away on the quiz time.
2,530.
2,530. You are on a roll. Good job. Did you correct me? Never. Okay. Good job. All right. It says explain the meaning, and that is our total distance traveled on the interval given from 0 to 50. And that's in seconds. And if the AP test says explain, you have to explain it. And the explaining part for the second portion, really in the end, you're just reiterating what was already stated to you. You didn't do any math behind that. All right? And that might give you an extra point, so why not? All right, Cody, part E, let's read.
Based on the values in the table, what is the fewest number of times that the acceleration of the car equals 0 on the interval 0 is less than t is less than 50? Justify your answer.
So the acceleration of the car could equal 0. So we have the acceleration is the v prime. So I'm going to go to my card real quick as a reminder. The acceleration is 0. If a number between 0 or positive and negative, what has to be right in between? If I have a positive and a negative number, there must be a 0. Okay, we're having a hard time here. So that means our velocity was changing directions. So let's see where the velocity is changing directions. So we have, it's going up and then down right here. So we know that slope is 0. Is there another spot that is changing directions?
45.
Okay, at 45. So we know slope is 0. So how many times is it changing directions? Twice. And that's because the velocity is changing directions. What if a student were to say it is going from increasing to decreasing and decreasing to increasing? Will that give you credit? Yeah, because you're being even more specific. So if you chose to say it is increasing to decreasing, and then it's going from decreasing to increasing, they mean the exact same thing. So if you say one or the other, it'll be good to go. So let's go to part B of number 1 on page 10. My last part, and I'm going to give you guys some time to study, okay? Part Part B. Part B has to do with single prime or double prime. When given the first, or not even a prime, it's asking for the double prime. So let's do a quick reminder. Gianta, let's read the number one scenario and then to part B.
The rate of fuel consumption in gallons per minute recorded during an airplane flight is given by the differential and strictly continuous function R of time t. The graph of R is equal to the values of R of t for the time interval 0 less than 30 to 10, t less than or equal to 90 minutes.
Just B.
The rate of fuel consumption is increasing fastest at time t equals 45 minutes. What is the value of R double prime of 45?
Okay. Oh, thank you. It is increasing the fastest at t equals 45. Now, is t equal 45 really like clear on the graph? So we're going to have to kind of figure out, well, it's somewhere over here. And if I were to kind of draw my dotted line, it is probably around here-ish. Now, can you guys tell right off the bat that is the highest that is increasing? It's increasing the fastest? Now, there's a reason behind that. What I want you to do is highlight the part before that point with one color, and maybe if you have another one, right after with another color. Look at the behavior of the graph. What is happening on the left side versus the right side that is opposite? It is growing, leveling down, or what's another word? Concave up and concave down, and I heard it, point of inflection. Very good. So if you look right here, when it is concave up and concave down, there's a point of inflection. So now let's see. It's asking us for R double prime. So would you guys agree, given the particle, our R double prime has to be the one that goes with the second one on the list? Okay? So that means it has to equal 0, because between positive and negative, there's a 0. So let's write on here, R double prime of 45 must equal 0 because the original graph, R of t, has a point of inflection. So those of you guys that said it is concave up to concave down, that's fine. You're describing the point of inflection. Okay? Is everyone good on that? So I know this was also part of our notes.